Hello and welcome to Learning Factory. In this video, we are going to solve a problem on hierarchical clustering. Hierarchical clustering is a kind of clustering algorithm that too has different mechanisms for implementation. So we'll be focusing today on a problem solving based upon single linkage hierarchical clustering. So let's see the problem statement. Given 5 data points and each point is described with two features A and B. So see here, this is the data that has been provided. So we are having 5 data points P1, P2, P3, P4, P5. Each data point is described with two features A and B. Cluster the points using single linkage algorithm. So this is the question that we have and we are going to solve this problem. The first step towards the solution is to compute the proximity matrix. So what is proximity matrix? Proximity matrix is a matrix with number of rows equal to n and number of columns also equal to n, where n number of points in our data set. So if we are having here 5 data points, then the proximity matrix for this problem would be of size 5 cross 5. So we are going to compute this proximity matrix. In this proximity matrix, we are having the distance between every pair of data points. So to compute the distance between data points, we will be using Euclidean distance. So Euclidean distance between two data points P and Q is given as square root of I equal to 1 to n Pi minus Qi square, where this n is total number of features. In our case, number of features n equal to 2, right, with respect to this Euclidean distance. So let us see one example how we are computing the Euclidean distance. So if we would like to compute the Euclidean distance between point P1 and P2, P1 is described with two features A and B, P2 is also described with two features A and B. So we are having here the difference between the respective features of two data points and square of that. Difference between two respective features and square of that. Summation of these two squared differences and then square root of the entire quantity. So this will give us the Euclidean distance. So Euclidean distance between P1 and P2 can be computed as 1.04139. So this is how we need to compute the distance between every pair of data points. So this would be a symmetric matrix, of course. So see here, distance between P1 and P1 should always be 0 because these are two same data points. Similarly, distance between P2 and P2, P3 and P3, 0. So the diagonal elements in this proximity matrix are always 0. As I stated, this is the symmetric matrix. We are not going to fill up the entire matrix, but we will be filling up only the half portion of this matrix below this diagonal, right? So see here, this distance between P1 and P2 is computed as 1.04139. So we are writing here the distance between P1 and P2 as 1.04139. Similarly, we are computing the distances between all the pairs of data points. So P1 and P3, P2 and P3, P1 and P4, P2 and P4, P3 and P4 and so on, right? So this is how we are computing our proximity matrix, right? Now, once we have computed the proximity matrix, then we are going to proceed with next step of our algorithm. Now, this is our proximity matrix that we have computed. Now, what we are going to do next is we will be finding out the minimum distance between the clusters, right? So, we'll be treating each data point here as individual cluster, right? We are treating each data point here as individual cluster. So whatever proximity matrix that we have computed, actually this proximity matrix is giving us the distance between individual clusters, right? So after computation, we are going to find the minimum distance between the clusters in this matrix. So if we look at all these quantities, the minimum distance is this 0.30232, right? So this is the minimum distance between two clusters P3 and P4, right? So what we are going to do is we are going to merge these two clusters together. So P3 and P4 we are going to merge, we are going to cluster, right? So we are going to form a new cluster of these two data points P3 and P4, okay? And the next step is we are going to draw a dendrogram. Dendrogram is a graphical representation of the clusters, and that is being used to find the number of clusters at the end, right? So how we are going to draw the dendrogram? So see here, on horizontal axis we are having the clusters or the data points, okay? And what we have done now, we are clustering data point P3 and P4, right? On vertical axis we are having the distance, right? So the distance between these two clusters P3 and P4 is minimum, and that is 0.30232. So height of this dendrogram between these two clusters P3 and P4 would be 0.30232. So this is how we are drawing the dendrogram. So please see here, whenever two clusters are merged, join them in this dendrogram, and the height of the join will be the distance between these data points or these clusters. So this is how we have computed the dendrogram for these two clusters P3 and P4. Now the next step is we would like to update the proximity matrix. And while updating proximity matrix, now here we need to make use of single linkage as stated. So let's proceed now. So this is the proximity matrix that we have, and now what we are going to do is, this is the minimum distance that we have computed, and we are supposed to cluster P3 and P4. So once again we need to compute, or we need to update our proximity matrix such that we are now depicting here the newly formed cluster. So P1 would be as it is, P2 would be as it is, P3, P4 now belong to one cluster. So we are having one cluster P3, P4 and P5. So overall now in this step we are having 4 clusters. Now we would like to update this proximity matrix, and to update this proximity matrix we are making use of single linkage algorithm for clustering. So what we mean by single linkage algorithm? In single linkage, what we are going to do is we are going to find out the distance between the clusters, right? Now in one cluster we may have more than one points, so we will be computing the distance between each pair of points belonging to the respective clusters, and whichever is the minimum distance, we'll pick that minimum distance as the distance between these two clusters, right? So see here, if I want to compute now P1, distance between P1 to P2, it has already been computed, correct? So we are having already this distance 1.04139. Distance between P1 and P1 is 0. So all diagonal elements would be 0. Okay. And distance between P1 and P2, already we have that. Okay. So we are going to replace it as it is. Now we want to compute now the distance between P1 and this cluster P3, P4. So according to single linkage algorithm, we will be computing the distance, or we will be looking at the distance between P1 and P3, P1 and P4, right? Because in one cluster we are having only point P1, in another cluster we are having 2 points P3 and P4. So we'll look at the distance between P1 and P3, P1 and P4, and whichever is the minimum distance, that would be the distance between these two clusters P1 and P3, P4, right? So let's see how we are going to do that. We want to compute the distance between P3, P4 and P1. So we'll be considering the distance between P3 and P1 and distance between P4 and P1. So distance between P3 and P1 we already know, it is 0.59304, right? And distance between P4 and P1 also we know, that is 0.46098. So out of these two distances we are going to pick the minimum. So minimum is 0.46098. So that would be the distance between P1 and P3, P4. So here we will be replacing 0.46098. Similarly, now we need to compute the distance between P3, P4 and P2. On similar lines, please once again I'll be highlighting we are using single linkage, and in single linkage we are considering the minimum distance between the data points in the clusters. So if we would like to compute now the distance between P3, P4 and P2, we will be considering the distance between P3, P2 and distance between P4, P2, and we'll be finding the minimum out of that. So distance between P3, P2, that is available 0.77369, and distance between P4, P2, that is also available, it is 0.61612. So minimum of that, so the distance between P3, P4 and P2 would be 0.61612. On similar lines, we'll be computing now the distance between P3, P4 and P5. So P1, P5 already known, 0.81841. P2, P5 already we know that, 0.32388. So the distance that we would like to compute is now P3, P4 and P5. So to compute it, we'll be looking at the distance between P5, P3, which is 0.45222, and distance between P5, P4, that is 0.35847. So minimum of these two would be 0.35842. So we will be replacing it at this place, 0.35847. So please note, we are making use of single linkage algorithm, and that is why we are making use of minimum distance between the pair of data points in individual cluster, right? So this is how now we have got this matrix, proximity matrix, which is updated. So in the next step, we will be using this updated proximity matrix and will be following the similar steps. So let's see here now. This is our updated proximity matrix, right? Wherein we are having now this cluster of 2 points P3 and P4. Now on similar lines, what we are going to do next is we are going to find the minimum distance between the clusters. So here we are having the minimum distance between two clusters, and that is 0.32388. Okay, so this tells us that we need to cluster these two data points P2 and P5. Okay, so we are going to cluster now P2 and P5, and we are going to update the dendrogram. So earlier we have clustered P3, P4. Now we are going to cluster these 2 points P2 and P5, and the length of this dendrogram or the height of this dendrogram would be the distance between these two clusters, and that is 0.32388. So this is how we are going to compute the dendrogram. Now once the dendrogram is computed, we need to update the proximity matrix. So once again, to update the proximity matrix, we'll be using the single linkage hierarchical clustering algorithm, right? So see here, this is the earlier proximity matrix that we have. This is the minimum distance that we have identified, and now we would like to cluster P2 and P5. So see here, now in this proximity matrix, we would be having P1 as individual cluster, then P2, P5 another cluster, and P3, P4 one more cluster. So once again we need to update the distances in this new proximity matrix. So the distance between P1 and P1, obviously it is 0, P2, P5 obviously it is 0, and P3, P4 also it is 0. Now what next? We need to compute now the distance between P1 and P2, P5. So see here how we are computing the distance between P2, P5 and P1. So we'll be looking at the distance between P2, P1 and distance between P5, P1. So in the old proximity matrix, we have the distance between P2, P1 as 1.04139 and P5, P1 it is available 0.81841. So minimum of these two, so it is 0.81841, right? So similarly, we'll be computing the distance between P2, P5 and P3, P4. P2, P5 and P3, P4, right? So to compute this, already we had this cluster with us, P3, P4, right? So we need to compute now the distance between P3, P4 and P2, right? And P3, P4 and P5, P3, P4 and P5. So these two distances we need to compare. So P3, P4, P2 distance is 0.61612 and P3, P4 to P5 distance is 0.35847. So pre-computed distances in the earlier iteration we are making use of, okay, and we'll be finding out the minimum. So the minimum is 0.35847. Okay, so the minimum between P2, P5 and P3, P4 need to be replaced as 0.35847, right? Now distance between P1 and P3, P4 already we know that, so we are going to replace it as it is 46098. Okay, so this is how we are supposed to compute the distances. So finally we are having this updated proximity matrix, right, that we would be using in the next step. So this is our new proximity matrix. Okay, now what we would like to do next is, once again we'll be looking at the minimum distance. So this is the minimum distance. So now we need to cluster these two clusters. Which are those clusters? Those we would like to further group: P3, P4 and P2, P5. Okay, so finding the minimum distance. So it is the distance between P3, P4 and P2, P5. So we are going to form the cluster of P3, P4 and P2, P5, and we are going to update the dendrogram. So see here now, P3, P4 was one cluster, P2, P5 was another cluster, and now we are going to merge these two clusters together. Okay, so we'll be having now the dendrogram from this cluster. So midway in between this P3, P4 and midway between this P2, P5 will be having the vertical lines, and once again the height of this dendrogram would be the distance between these two clusters, right? So this is how we have updated this dendrogram. And now the next step is, we also would like to update the proximity matrix. So to do that, see here, this was the old proximity matrix that we have. Now we are going to group P2, P5, P3, P4 together. So we'll be forming one cluster out of that. So now, before we had three clusters, now we are having only two clusters, P1, and rest of the 4 points are in another cluster. So P2, P5, P3, P4 would form one cluster. Now on similar lines, we will be using the formula to compute the single linkage distance between the data points or the clusters. So we are supposed to find the distance between the cluster P1 and the cluster comprising of these 4 points, P2, P5, P3, P4. Okay, so in this old proximity matrix, we know the distance between P2, P5 and P1. We also know the distance between P3, P4 and P1. So we'll be computing now the minimum of these two distances, right? So P3, P4, P1 and P2, P5, P1, these distances are available. So we'll be computing the minimum of these two. And this is how we are replacing this distance as 0.46098, right? So obviously the distance between P1, P1 is 0, distance between P2, P5, P3, P4 and the same cluster is also 0, right? So now this is our 2 by 2 matrix. Okay, now once again we'll be looking at the dendrogram. So till this we have already done. Now we would like to cluster these points P3, P4, P2, P5 and P1. So from P1 we are having vertical line. From all these, or this cluster comprising of all those 4 points, we are having the vertical line, and whatever is the minimum distance 0.46098, that would be the height of this dendrogram. Okay, so this is how we have plotted the dendrogram. And now the next step that we are going to do is we are going to form the clusters using this dendrogram. So there is one way to come up with the clusters based upon the dendrogram, and that is we are going to set a threshold distance and draw a horizontal line. Generally, we should try to set the threshold in such a way that it cuts the tallest vertical line. So in our dendrogram, the tallest vertical line is this, right? So it should cut the tallest vertical line. Okay. So let's set this threshold as 0.4. Okay, and let us draw the horizontal line at that threshold. So please note, whenever we are selecting this threshold, it should cut the tallest vertical line, and we should make sure that it is not cutting, while cutting this, we should make sure that it is not cutting the other vertical lines, right? So the number of clusters equal to the number of vertical lines which are being intersected by the line drawn using the threshold. So this line, horizontal line, is intersecting these two vertical lines. This is 1 and this is 2. So these two lines are being intersected by this horizontal threshold line, and that is the number of clusters those we may have, right? So unlike k-means clustering, we need not provide in advance the number of clusters in this algorithm. In hierarchical clustering algorithms, at the end, using this dendrogram, it would be possible to find out the number of clusters. So in our case, we will be having 2 clusters, right? One cluster will have only one sample, that is P5, and another cluster will have 4 data points, that these are P2, P3, P4 and P5, right? So this is how we have solved the problem. Okay, so I hope you must have understood this. So congratulations, we have solved the problem. Thank you for watching and happy learning. Please subscribe this channel, like, comment and share among your friends. Thank you.